Hello, does it work? Yes, sounds. I think we are ready to start. So I'm going to take this one. So today, thanks for joining this presentation about Trust but Verify. My name is Olivier. I'm working for Suse as an engineering manager on the Rancher side, so I'm working a lot on all things related to containers. You can reach out on Twitter if you want. Most of my work is open source, so you can follow also my work on GitHub. Quick disclaimer, I'm not a native speaker, so I may be using the wrong wording during my presentation. Feel free to come after the presentation to correct me if I'm wrong on something. So what I want to talk today is the right level of trust, because trust is a broad term. It can mean different things to different people, and in my case, I spend a lot of time working on the Jenkins project. So more specifically on the Jenkins infrastructure project. So it's an open source project with a lot of contributors, but the main difference is we don't build software. We build all the tooling for releasing Jenkins, retrieving documentation for the Jenkins project. So everybody is invited to contribute to it. But the thing is, we need to trust each other's and the work that we are doing on this, because you have a lot of community members everywhere on the world contributing to the projects. And so trusting what we work on can be really challenging. And so the first thing is I want to talk is trusting the system that we rely on. The Jenkins project received a lot of sponsoring. So we have a lot of compute, different clusters, Kubernetes cluster, virtual machine, and so on. And what we learn is when you have to operate large amount of machines, something that can work one day will not necessarily work after, the day after. The reason for that is the good situation is you just have more trust. Your project is successful, you have more people using your services. You have just more people using your services. On the other side, you may be affected by security issues or whatever. So you always have to consider that the infrastructure that you rely on is not trustable at 100%, and you want to put in place practices and policies so you reduce the risk of seeing your system going down. So I'm going back to this one a bit later. The next things that I find challenging, and it's not nothing specific to the Jenkins project, but it can be to any project of any size, is the amount of technology that you need to work on. And so you first need to be confident in yourself, in your own limits, in your own abilities to change something. But at the same time, you also need to be aware that you don't have the time to master all the technologies, you don't know everything, and sooner than later, you need to reach out to those other people, or once again, put in place practices, policies, rules that can help you reducing the risk of introducing mistakes. The final challenge that I found when you want to trust is the other people, especially when you work on a large community project like the Jenkins project. Because on one side, you think, okay, all those contributors can bring you something that you didn't think about at the beginning of the project, because those people have issues that they want to solve. They're really helpful. But on the other side, those people can introduce mistakes because they don't know everything like you do. They don't have your experience like you do. And so you need to find the right balance between giving your trust in the people so they can achieve things, and on the other side, protecting the rest of the group, because once again, we all do mistakes. And so for the little story about this picture is, while working on the Jenkins project, I would regularly have people reaching out to me asking, okay, they want to maintain a specific service, and can they have, for example, the SSH keys to the machines, for example, or can they have the Jenkins code signing certificate because they want to experiment with it? And each time someone would come to me asking that kind of questions, obviously for a code signing certificate or the Jenkins.io certificates, it's just a no-go. But you need to understand what that person wants to do, what that person wants to bring to the project, and maybe you can find a middle ground. And just what you're trying to do here, you're just trying to reduce the risk that you have when you collaborate with the people. So what I want to say here is, when you're responsible for the full life cycle of a project, you have risk everywhere, and you want to put in place policies, practices, and so on that can help you to mitigate that risk, and so to increase the confidence that you have in your projects, in your infrastructure, and in yourself. So if, like me, you don't necessarily trust the project, the system you rely on, because, yeah, we never know what can go wrong. You don't have the time to master everything, because sooner than later you have to work on a technology stack that you don't necessarily master, or maybe you just have to work on old legacy and you forgot about those. But yeah, you need to be pretty confident about your own limits. And finally, if you prefer to empower people around you to do the work because they may have that complementary skills that you don't have, then I want to talk about and introduce policies. So a policy is a contract that you can have between machines, between you. So we are all talking about the same thing. And when it comes to collaboration, you have these two different ways to see the people working on a specific project. So I'm not talking about how you should organize your team, but you usually have the dev people who will just try to introduce changes, build that new feature, that new shiny things that does not exist yet. And on the other side of the spectrum, you have those people responsible to run your infrastructure in production. And once again, trusting infrastructure can be challenging, and so if you can introduce as little change as possible, that's just better. And so several years ago, not more than several years ago, we started to see a shift where now the two teams, the two objectives are merged, because in the end what we want is we want to deliver value, but those two groups of people can work together and rely a lot now on containers, because it allows you to have reproducible and immutable environments on everywhere. So from the dev machine, for example, you could have a Kubernetes cluster, so it's just an API running, just an API on top on infrastructure. And so there are a lot of tools that you can have on your machine, and on, for example, like Rancher Desktop or K3D or whatever other Kubernetes engine you want to use. And on the other side, you have, you use managed Kubernetes clusters, you have bare metal Kubernetes clusters, and so on. But the good thing is we now have a foundation, an API that we can all talk about the same thing. This means that we can easily put in place policies that will affect the production cluster, the CI cluster, or even your local clusters, because, well, we don't necessarily have the same experience. So what I want to talk here is the different kind of policies that you can have on Kubernetes that can use across the different teams. So you obviously have the first one, which is the role-based access control. So you just authorize who has access to the control or to the cluster and who doesn't have. In terms of collaboration, all it says is some people can break the cluster, others can't, but that's it. What I want to really insist is the next three. So the first one, so the pod security policy. So pod security policy is a specific policy that you put on your pod, on your Kubernetes cluster. And what you want to say is you want to enforce some good practices. So one of those good practices is you should not be running a container with a root user in a privileged environment. That's something that many people show that it's a really bad practice, and still we can do that by default. And so the pod security policy, we just assume that we are not all expert at all the different ways to exit a container, but just by enforcing some default policies, we can reduce the risk of breaking your infrastructure once you are in production. The network policy is the same, except that this time we don't have to be a network engineer. We can just rely on other people's experience to say, okay, we can enforce some policies, so we reduce the risk of breaking our clusters. But what I want to talk now is the admission controller. So the admission controller is, as they explained on the Kubernetes the documentation, it's a piece of code that can listen event going to the Kubernetes API, and then you can run some validation on those events. You can run some validation saying that the event is fine, yes, no, but you can also mutate an event. Mutate means that you receive an event, you're not happy with what the event is, and then you just change it a little bit so you can use that event and proceed. And so one of the projects that my team is working on is CubeWarden. So it's a policy engine for Kubernetes. The purpose of CubeWarden is to have simple policies in place. So I'm going to show you what it looks like. So this is a simple Kubernetes. It's a simple YAML resources, like if you're familiar with the way you configure your Kubernetes resources. You have custom resource definition, so it's a CubeWarden one. You have, in this case, the kind. So the kind define, okay, this policy should be applied to the whole cluster, or you can also have just admission policy if you want to apply a policy to a specific namespace. Again, a policy is a contract between the people. So what is really nice when you can have that kind of policies is you don't necessarily only have security in mind, you can also focus on the collaboration between the different people. So it's a simple admission policy. Now you have the specs. In the spec, the first line is a module. The way CubeWarden handle policies, the way you can have different kind of policies is using different OCI artifacts. So CubeWarden generate, when you build a policy, you generate a WebAssembly binary, and then you distribute that WebAssembly binary on OCI registry. Other people can just reuse this one. So as a policy maintainer, all you need to do is just use the language that supports OCI binaries. So for example, Rust, Golang, or Swift. I mean, there are a few others. And the thing is, you can just reuse the programming language that you want to use. You distribute it on a OCI registry, and other people can start using your CubeWarden policy. Then you have the rules. The rules is, as I said, you have an event going to the API, to the Kubernetes API, and then you have the admission controller that catch that event. And so in this case, we want to detect, okay, when are we creating or updating a pod in our, for example, cluster. And the policy that we need to apply is the one explained in the settings. So I will come back. Then you have the mutating, so we can mutate an event depending on the policy. And finally, we have settings. So in this case, the policy says you should reject any container using the tag latest. Because once again, we know that it's a bad practice to use the tag latest, especially in your CI environment, because then you have no idea about what you are using, because the latest tag means different thing if you're on your machine, in the CI cluster, or in production. So we could just enforce some rule. So the people who are not necessarily familiar with this rule will not be affected by this one. As I mentioned, there are other policies. So this one was just to reject container based on tag, based on repository, and so on. If we are looking for other policies, we can go to up.cubewarden.io, and there we have, for example, this one is a verify image signature. So we want to be sure that the container, you running in a container is assigned using Sigstore. And so you have the policy. We have free information on this page. So when, of course, you have the title and the description. But at the bottom right, you have 3 icons. The green shields mean that this policy has been signed using Sigstore. The red pencil means that this policy supports mutating. So you can, for example, if someone is not familiar with the policy, you can still let that person do the thing you want to do, but just dropping what you consider to be a bad practice. And finally, you have the AV button that tells you if it validates the event or can reject the event. So the good thing, what is great in this way is, as a developer, you can put as a developer, you can put all the complexity that you want in your policy, so you can use the language that you want, and you can reuse your ID, you can reuse your practices in the team, and then you can just expose a simple configuration that people can use, for example, using the YAML file. So in the end, it's just a WebAssembly binary. You compile it to a WebAssembly binary, distribute it on a CI registry, and job done. So you can see WebAssembly binary as that universal way to build and ship binaries. So if you want to see what CubeWarden looks like, well, it's pretty. Let me show you. I'm going to change my screen so I can do a mirror. Sounds like you see my same thing like me. So, okay, great. So I have a local, I'm using K3D in this case. Okay. So I have a cluster running on my machine, kubectl get admission. So I installed 3 policies by default, so they were just chart templates. So those are just 3 basic policies. So what I want to show is, from a Kubernetes point of view, I can just enforce some common practices, like, for example, not running a container using the tag latest. And on the other side, from my Jenkins instance. So this is simple Jenkins instance. So not configured with Git configuration, nothing else, it's just like standalone, because I didn't know what internet connection would look like. So what we do here is, if I go to the pipeline configuration, all we do is we want to trigger a job running on a cluster using the Maven latest. And what we want to do here is we want to reject this container. What is interesting with policies, it's not only about, for example, enforcing some security practices. You can also, for example, enforce some good practice in the labels. So, for example, if you want to use environment using development or production, you can do a lot of things with a policy. Because in the end, what you want is you want to increase the collaboration between the different person. And so if you run this, or I can just reuse an existing one that I was trying this morning. So you see that the CI job will just be rejected because we don't want to be using the container, where is this? We don't want to be using the tag latest. So import the tag latest. So the feedback loop is pretty quick. And so now we can go back to the developer and say, okay, it sounds like you were trying to do something bad because you don't know which version of Maven you're trying to use here. You don't know which version of Java you have in the container Maven. So you really want to use the version. And so, yeah, I just run the job, and it's here. So once again, we do have, so I don't have right now data on this one because I misconfigured something, but what I want to mention is CubeWarden exports the metrics to a Grafana, to a Prometheus, so that then you can just build a dashboard that you want, and we also start working on an integration within Rancher. So yeah, there is no really shiny because thing when you look into policy engine, because all you want to do is you want to validate or reject an event. So yeah, what I want to say here is that's fine to not master everything. We can all leverage other people's experience. So by just using policies, we can just, we all do mistakes, and yeah, using policies is not that difficult. Thanks, that's it for me. If you have any questions on the CubeWarden project, you can just go on Kubernetes, on the Kubernetes Slack, and then go for the CubeWarden channel. Thanks. Any question so far? One question on the right. So I don't have advanced experience, for example, for Kyverno or Gatekeeper. Gatekeeper, for example, rely on Rego. So you have, depending on the rules that you need to put in place, Rego can be difficult. It's a new DSL that you have to learn. So that was pretty much the first one. When people started using Gatekeeper, for example, you also see Kyverno was introduced. It's a second policy engine that you can use, where you configure everything from the YAML. What is interesting with CubeWarden is, depending on the complexity that you want to have, you can just reuse a programming language that you want to use. So if you have a very, very complex policies that you need to build for your custom resource definition, using CubeWarden, just build it using, for example, again, Golang or Rust. So you just reuse a language that you're familiar with, and voila, otherwise you just, as a user, you can just use simple YAML files. Any other question? Sounds good. Thanks for listening. And yeah, before I leave, I have a last-minute presentation on a topic that I like, which is dependency management, and a project that I started. And so it will be in the room next to this one at 11:30.